One of the things that we study when we study exponential growth and decay are some different formulas. And one of the formula tells us if we have continuously compounded interest. And the formula is the amount in your account, that's what A stands for. P is your principal, the amount you invest or put in the account. 1 plus R is the rate, the percentage rate, but you're going to write it as a decimal. N is the number of terms it's invested, and that's, the number of times per year. So N is the number of times per year that you're going to compound that interest. It's not continuously compounded, it's just compounded interest, number of times per year. And then you multiply to the N, and then T is the number of years. See, R is the rate. Okay, so I'll write that percentage rate. But you're going to always plug it in as a decimal. A is the amount in the account, and P is the principal. So this is the formula we need to do number 1. And so they tell us that we have $1,000. That's our principal. It's invested at 12% interest. Wow, we'd love to get that those days. This is going to be my R here. Up here, this is my P. But my rate, I never plug in a percentage rate as a percent. I always write it as a decimal. It says it's compounded annually, so number of times per year that it's compounded is 1 time per year. That's what it means to compound annually. And it says determine how much the investment is worth after A, 1 year, so you're going to plug in T is 1 into the formula for that one. For B, it's going to be 2 years, so T is equal to 2. For C, 3 years, so T would be 3. That you're just changing the number of years so you can see how much you get. And then T equal 10 years. So in these problems, all you're going to do is basically you're going to use that formula over there. So the amount in the account is what you're trying to find, the A. Your principal is 1,000. And it's 1 plus, my interest rate is 0.12 over the number of times per year I'm going to compound, which is just once since we're compounding annually. And then we're going to multiply it. N is 1, and then T is, in this case, 1. So 1 times 1 is 1. Okay? So this is just going to be 1,000 times 1.12. And if you put that in your calculator, you're going to get, you just basically move your decimal place over 3 spaces, wouldn't you? It'd be 1120. Okay? Now I'm going to do another one. I'll do D. Okay? I'm going to leave some of these for you to do. So I'll do 1A and then I'll do 1D. Okay? So for D, we're going to do the same thing. We're just going to use the formula. Our P is still $1,000. That's what we put in the account. The R in that formula up there is still 12%, so we'll write 0.12. We're still only compounding annually, so that's going to be a 1 because N is 1 time per year. And then it's 1 times 10, which 1 times 10 is 10 up here. So this is going to be 1,000 times 1.12 to the 10th power. Well, you're going to need your calculator for this. And so if you stick this in your calculator, I'm going to do the 1.12 raised to the 10th power first. Okay, so I've got that. And then I'm going to multiply by 1,000 in my calculator. And I get 3105.85. I got 848, so I'm going to round that up to 885. And then that's how you do that. So I know you can do the same thing, it's just you're plugging in a different T each time, but there's at least the 1A and B for you. Number 3, I'm not going to work, I'll do one of those. This time I'll do 3. You're supposed to redo exercise 1. I'm going to choose B this time. Redo it assuming the interest is compounded quarterly. Well, quarterly means 4 times a year, so that all that's changed here is my N is 4. My interest rate is still 0.12. My amount that I put in the account at the beginning, the principal, is still 1,000. For the B part, we're doing that for 2 years. Okay, so you're going to go back through 1 year, 2 year, 3 year, 10 years on all of these, but we're just going to do the 2-year one this time as an example. And let's see, anything else? Let's see, let's write the formula. A equal P times 1 plus R over N to the NT power. Okay, so we're just calculating the amount in the account again. Your P is 1,000 again. 1 plus, your rate is 0.12, but this time you're compounding 4 times a year. So N is 4. That's what's different between this and number 1. And then up here, it's to the NT power. Well, N is 4, and in this case, T is 2, so 4 times 2 is going to be 8. So you'll put this in your calculator. It'll be 1,000 times 1 plus, I'm going to go ahead and just divide that out separately. 0.12 divided by, 0.12 divided by 4 should be 0.03 to the 8th power. Well, it is 1,000 times 1.03 to the 8th power. And so if you put that in your calculator, I'm going to put in 1.03 raised to the 8th power first, and I get that number, and then I multiply by 1,000. Because remember, when you're doing PEMDAS, you have to do the exponents first. Okay, so it ends up being 1226.77 if you round it off. And so that's how you're going to do the number 3 on there. You just have to go back and plug in the values for each of the A, B, C, D part. Okay, in this problem, it's kind of hard. I don't see the book really giving you a good example of what to do here, so I'm just going to explain it to you. If you think about this, the value of the car, let's call it V, it starts off being $12,500, but if it stayed the same, we would have, for every year that passes, it would just be a 1 inside. It would stay the same. Nothing would ever, oh, no, that wouldn't be right. It would just, if it stayed the same, it would just be 1, okay? But as time passes, and each year that passes, we need to decrease the amount, okay? So now 1 would mean it stayed the same value, but if it's decreasing by 20%, 1 is like 100%. 100% minus 20% each year would mean that it's only worth 80% of what it was the year before. So if I put a 80 here, this is kind of like my, this is an exponential function. This is the number that you start with is like your initial value. This is your base, and t is how many years have passed. So it's like it's 100% minus 20% means 80% of the value of the year before. So if I plug in t is 0 when it's brand new, 0.8 to the 0 would be 1. Okay, so let's do that. That's actually what they're having us do here. If the first year, when you bought it, it's at t equals 0. 0.80 to the 0 power would just be 1, and you would have 12,500 times 1 would be the new value, okay? But after 1 year, how much is it worth? Well, it's not worth as much as it was. It's only worth part of what it was worth, so it's like 0.80, which I can write as 0.8. And after 1 year, it's just what's 12,500 times 0.8, or what's 80% of 12,500. We really didn't need, for year 1, we could have just said, what's 80% of 12,500? Well, it's only going to be $10,000. Now, we didn't need this fancy equation for year 1, but if we want to keep doing this, it's nice to have this equation because now I can keep figuring out stuff. For instance, let's see after 10 years, what's that car going to be worth? I'll leave the B and C part for you. Well, the value is 12,500 times 0.8, and this time t is 10 years. So let's calculate this. PEMDAS says you would do the 0.8 to the 10th power first. So let's do that. 0.8 raised to the 10th power, or you can type in 0.80 raised to the 10th power if you like that. It's like 0.107374, but I'm going to multiply that times 12,500. So I'm doing all this in my calculator. I'm just writing down what I put in, and the car is only worth $1,342.18. It's worth about $1,342.18. Not much after 10 years, is it? So you'll do the B and the C part, and all you're going to be changing each time is what you plug in for T. T is the number of years. All right, the book does have something to kind of help you out with number 7, but you have to really think about the values they're giving you. If you look at, there's a doubling time growth formula in your book, and there's a half, okay, so that's what we want. This is actually on page 484, and the formula says the number of bacteria that we have now is N naught. N naught stands for the amount you start with, okay? And they're not telling us what we start with here. They're just having us leave that in the formula so we could plug in, any amount we wanted to. So N naught's not going to get anything plugged in for it here. And then it doubles, so the factor that it's growing by is doubling. That's a 2. And then at the time t, it's given by t over d. If you look at that formula, where t is d is the number of years, or the number, we could do the number of weeks here since they're giving us weeks. So we'll let D be the number of weeks, and T is how many weeks have passed. So the D one tells us how many weeks it takes to double, and then the T part tells us how many weeks we're actually looking at, okay? So the formula we want would be N naught, which again, we're not going to plug anything in for that, and then the T, we'll plug in, that's the number of weeks in the A, B, and C part. And the D part, the weeks it takes to double, is 3. So it would be N naught times 2 to the T over 3 power, okay? Or you could put W over 3. I'm just going to use T, all right? But T is the number of weeks, okay? So if you check the answer book and it uses W, you can just replace the T with the W. All right, for A, the number of bacteria is N naught, whatever amount we start with. We don't know. We don't really care. We're just going to leave that in there. And it's 6 over 3 because T is 6 weeks over. So it's actually had time to double twice, hadn't it? So this is going to be N naught times 2. 6 divided by 3 is 2. 2 squared is 4. So that's going to be 4 times N naught. And when they put that little 0 there, you pronounce it naught. And it basically it just means your original value. N of O, you could think of it as your original N value, but you pronounce it 4 naught. Okay, so you're going to do the same thing for B. And if we want a general, I'll let you do B. All you got to do is, instead of plugging in 6, you plug in for T, you're going to plug in 15 on B, okay? C, they're asking you for W weeks. They just want the formula here, okay? So the formula was N equal N naught times 2, and instead of plugging in a certain amount of weeks, they're calling the number of weeks W over 3. So that's basically it right there. That's the answer. It's just basically having you write the formula. The book, I think the book answer key writes it like this, with the N naught multiplied on the N. I don't know why they do that, because most of the time you'd always put your original number out front. It's not a big deal. It's the same thing either way. Okay, I went ahead and wrote down the facts on number 9 so we could get through it quickly because I know I'm running out of time for the video. They tell us, we're talking about carbon-14, its half-life is 6,000 years. So the half-life, that's going to be the H in our formula. Here's our formula from the book. It was in one of those, in that little square on page 485. I copied it down. Your original amount is 100 kilograms. That's your N naught. Okay, your beginning amount, and 12,000 years is your time. And since both this and this are in years, we're good to go here. So all we got to do is say the amount we have is the N naught, which was 100 kilograms, times a half, and then the T in this value, in this equation was 12,000, over the half-life was 6,000. Well, that's going to simplify kind of easily because 12,000 divided by 6,000 is actually 2. So it's 100 times 1/2 squared, which would be a fourth, and you'd be left with 25 here kilograms. So that's what you're going to do on this one. You're just going to plug in a different number every time for the T, the time. So you're going to do the same thing. It's just that right here you'll have a different number to plug in for each one of those.